Hello, I'm John Linford. I work for ARM, and I want to present a few numbers from BLIS Performance Projections on future ARM CPUs. The question I'm trying to answer is, will the SVE code developed on A64FX today port forward to a future CPU, the Neoverse V1? This is a CPU ARM is developing currently and will soon be available in a matter of months, in fact, in partner products. So we want to know, what is the readiness of the HPC ecosystem for this platform? In my talk, I'm going to present two CPUs that implement ARM's scalable vector extension, the A64FX from Fujitsu and the Neoverse V1 from ARM. I'm going to talk a little bit about our simulation process for these future CPUs and how we can run small representative kernels in simulation to gather performance data and understand the performance of these applications and try to take a guess at what they might do at scale. I'm going to show how you can build BLIS for use in simulation, which turns out to be very easy and quite nice. And I'll present some experimental results from our simulator with using the A64FX as a reference point for performance. Quick look at the Neoverse V1. This is ARM's highest performance core to date, and as I said, it should be available in partner products within a matter of months. It does implement SVE, and it implements it with two 256-bit SVE units per thread. So there's a decent amount of floating point performance here. And to summarize our findings, we find that the BLIS SVE kernels do in fact port forward very nicely to the Neoverse V1. The performance is frankly excellent out of the box. Just recompile with the appropriate architecture specification and run on the V1 simulator. And we see that the efficiency of the L3 BLAS kernels is very good, usually matching or beating the A64FX in silicon for the same problem size. The A64FX does have a higher overall theoretical double precision floating point peak. So the V1, of course, is not achieving the same level of performance in terms of raw numbers, but it is getting better than 50%, which, considering that the V1 has half the vector bandwidth of the A64FX, speaks to the generational advancements in the Neoverse V1. We also see that the LLVM and the GNU compilers are ready for the Neoverse V1. That I did not observe any kinds of performance or correctness issues in the kernels that are written in high-level languages, not written in assembly. Everything basically just works, which is really great. So come to my talk. I'll show you some detailed performance information that's behind this chart. I'll talk about the performance monitoring units that we have in our simulator and cover your questions at BLIS Retreat. See you there. Bye.